Welcome to lesson 3.4. This lesson is going to be a little bit different from what we've been doing. It's going to build on the systems of inequalities, but the idea behind it is just a little bit different. It's kind of giving a reason to why we do systems of equations, or at least one reason why. So we are talking about linear programming today, and linear programming is a technique that helps us to identify a minimum or maximum value of some quantity. So the best example I can give is that businesses want to maximize or minimize either profits or costs. And so they might use something like this, like linear programming, to figure out how many pizzas do we need to make each hour to maximize our profits? How much money should we spend on advertising to minimize our costs? And so that's kind of what linear programming is going to be. Linear programming involves an objective function, and an objective function is just a function that gives us that maximum or minimum value. We are going to plug in some points and find which one is the maximum or minimum. The constraints are any limits on the variables. So if you think about it, when we're talking about putting this into real world perspective, if we're talking about pizzas, for example, and based on how many hours, I can't make a negative number of pizzas. I can't work a negative number of hours. So there are constraints. In that case, we would need to look only at positive numbers. And usually with linear programming, it's going to involve only the positive numbers. And then the feasible region contains all the points that satisfy all the constraints. So thinking about when we did systems of equations, when you had two equations like this, it might have just been like that was your solution because that's where they overlapped. But now we're going to throw in like maybe an equation here and an equation here, and this little spot in here is going to be your solution. It's going to be more like 3 or 4 inequalities in one problem. But let's jump right in. We've got some instructions here. The first thing, we're just going to take it step by step. It says to graph the system of constraints. So if I look at this first inequality, it's in standard form, so I'm going to find my x and y intercepts. I get x equals 5. And I get y equals 5. So I'm going to put both of those points on my graph, and I'm going to connect them with a solid line. Oops. There we go. And then if I plug in my test point of 0, 0, I would get 0 is less than 5, and so I would shade in this direction. Let's change colors just so that each one's a little different. Here my x-intercept is going to be 8 and my y-intercept is going to be 4. So I'm going to graph x equals 8, y equals 4, and I'm going to connect those with a line. Plug in 0, 0, I'm going to shade in the direction of 0, 0 because it's a true statement. So before we would have said that this is our answer, but we're not done. We have 2 more inequalities to graph. We have x equals 0, and do you remember, does x equals 0 make a vertical line or a horizontal line? It makes a vertical line through the point x equals 0. So there's our graph of x greater than 0, or equal to 0, excuse me. And it's going to shade to the right because we want numbers that are bigger than 0, so those positive numbers. And then for the y, that's too close to the other green. It's purple. Y greater than or equal to 0 will be horizontal because it passes through the y-axis at the point y equals 0. And again, it's greater than 0, so I want positive numbers which are above that line. So now when I look at where all of these overlap, remember the red and the green all went down here, but I'm only looking at positive numbers. So my feasible region, where all of the solutions are, is going to be right in here. And what this does is it actually makes a quadrilateral kind of looking thing, a shape of where our feasible region is. These are the boundary lines. We've got a line here and a line here. So we've graphed our solution, and anything in this region is a solution. If I plug in 2, 2 to each of these, it's going to give me a true statement. But we're going to name so we've done the graphing, but now we need to name the vertices of this shape. So I have one vertex here, I have one here, and one here. Basically, there's a vertex anywhere the slope of the line changes. So like right here on this part, the slope is -1/2, but then you can see here it changes to -1. So if you are having trouble with that, we can talk more about it at a later time. So when I label my vertices, I'm going to get 0, 0. I get 5, 0, 0, 4. And then this point right here is 2, 3. So what I'm going to do with this now is I'm going to take each function, or sorry, each ordered pair and plug it into my function. This is my objective function here. And we're going to find which one maximizes it. And maximize means biggest, so we're going to see which one gives us the biggest value. All right, so when I plug in 0, 0 to that function, I get 0 plus 3 times 0, which is just 0. When I plug in 5, 0, I get 5 plus 3 times 0, which gives me 5. 0 plus 3 times 4, which is 12. And then 2 plus 3 times 3, which would give me 11. So it looks like the answer is 0, 4. 0, 4 is going to be the one that maximizes the function. So let's look at a real world example that will hopefully help us understand kind of what all of this is saying and what it means. So someone's going to make, maybe not you, but someone is going to make and sell lotion. And they're selling a quart of regular lotion with 2 cups of oil, 1 cup of cocoa butter. But they're also making extra rich lotion. And that has 1 cup of oil and 2 cups of cocoa butter. And then it says you'll make a profit of $10 per quart on regular lotion and $8 per quart on extra rich, not extra rick lotion. You have 24 cups of oil and 18 cups of cocoa butter. So how many quarts of each type of lotion should you make to maximize your profit? So I know how much of each ingredient goes in the 2 different types of lotion. So what I'm going to do is first decide what my variables mean. I'm going to say that X is how many quarts of regular lotion we would make, quarts of regular. And then the Y is going to equal how many quarts of extra rich. So when I think about this, I'm going to think about first writing an equation for how much oil we have. So thinking about just the oil. So looking at this, I know in the regular, for each quart of regular lotion, there are 2 cups of oil. Oops, not CX, sorry. And for each quart of the extra rich, there's 1 cup, so plus 1's Y. And in total, we have 24 cups of oil. So actually, this needs to be less than or equal to. Do you know why it needs to be less than or equal to? It needs to be less than or equal to because we don't have to use all 24 quarts of oil. However, or whatever, cups of oil, excuse me. However, we can't use more than what we have. We can't make something using 25 cups of oil because we only have 24. So then if we think about the amount of cocoa butter, I'm just going to call it CB. There is 1 cup in the regular, and there's 2 cups in the extra rich. And this time we have 18 cups of cocoa butter. So there's 2 of our equations, but we need to think about for both X and Y, are there any other constraints we need to consider? Both X and Y need to be greater than or equal to 0 because you cannot produce a negative number of quarts of anything. That just wouldn't make sense. So here are our 4 equations. If we put them together, they look like this, and now we're going to graph them. So I'm going to find x and y intercepts. I get 24 and 12. I'm going to do x and y intercepts. And so I would have y is 9, x is 18. Don't worry, I'm going to go back and connect these. And then x equals 0, or well, x is greater than or equal to 0, and y is greater than or equal to 0. So let's see what those lines look like. I didn't think you'd want to watch me draw all those lines. So for y is greater than or equal to 0, it's going to shade above because I want the positive numbers. For x is greater than or equal to 0, we're going to shade to the right so that, again, we get positive x values. And then for both the other lines, because they're less than, they're going to get shaded below, toward 0, 0. And I should be careful. I shouldn't say since they're less than. It's not. That's not the reason we're shading this. It's because if I plug in the 0.00, it's true for both of them. So we have to shade in that direction. So the overlapping area, or the feasible region, is right here. So this is saying, like, I could make 4 quarts of the regular lotion and 5 quarts of the extra rich. I could make 8 quarts of regular and 3 quarts of extra rich, but I want to find what maximizes my profits. So if I look at this shape here, oops, and I find my 4 vertices, I've got one here, I've got one here, here, and here. And those points are 0, 0. That is 12, 0. 0, 9. And then this point is 10, 4. Now, if I plug each of these into the objective function, I'm going to get 10 times 0 plus 8 times 0. 10 times 12 plus 8 times 12, 10 times 0 plus 8 times 0, or 8 times 9. This should be a 0 up here, sorry. And then 10 times 10 plus 8 times 4. Now, here I would just get 0, which makes sense. If I produce none of either type, I'm not going to make any money. If I produce 12 quarts of the regular, I would make $120. If I do only 9 of the extra rich, I would get $72. And if I do 10 of the regular, 4 of the extra rich, I'm going to get 100 plus 32, which is 132. And that's my maximum value. So the suggestion here would be I should produce 10 quarts of regular, and 4 quarts of the extra rich. So this is kind of a lot to take in, and hopefully it kind of makes sense because we're really just applying what we've learned about graphing with with inequalities. We're just taking it a step further. And we'll continue to practice this, but in the meantime, if you have any questions about any of the examples that I did here, please let me know. I would love to go over anything with you and help answer those questions.